Question 18 in Chapter 16 asks you to indicate whether each of the following describes a competitive or a non-competitive enzyme inhibitor. So these enzymes are making reactions happen faster. The inhibitors of enzymes will slow the enzyme down so that a reaction happens more slowly. And you have two types of inhibitors. You have competitive inhibitors and you have non-competitive inhibitors. So let's consider those separately. So the enzyme works because the substrate, here this green thing, fits into the mouth of the enzyme, which would be the active site. And then the reaction happens and it spits out whatever it turns into. A competitive inhibitor has the similar sort of shape as the substrate. So here this orange shape is the competitive inhibitor. You can see how the point is similar to the green shape, the point on the green shape, which is the substrate, and it competes with it for the active site. Once that competitive inhibitor is in there, the substrate that usually fits into the active site can't get there, and so the reaction doesn't happen. So they're both of these two molecules are competing for the active site. That's the mouth of the Pac-Man. And when the inhibitor gets there first, it inhibits the reaction from happening. It slows the reaction down because it inhibits the enzyme from working. So it is a competitive inhibitor. Now notice, if you add more it's completely a matter of which one gets there first. If you add more substrate, then the likelihood that the substrate gets there first is much higher. And so when you add more substrate with a competitive inhibitor, the inhibitor tends to not work as well. On the other hand, if you have more of the enzyme, or of the inhibitor, then the inhibitor is more likely to get there first, and then the inhibitor would be more likely to get there first, and you would make the reaction slow down. So with competitive inhibition, how you can reverse the inhibition or not. You can make it more inhibited by adding more of the inhibitor, or you can make it less inhibited by adding more of the substrate, what the enzyme usually acts on. So concentration affects competitive inhibition. Okay, then you have non-competitive inhibition. So again, the substrate works by fitting into the mouth of the Pac-Man, which is called the active site, and then it spits it out as whatever molecule it needs to become. In non-competitive inhibition, the inhibitor doesn't try to fit into the active site. It has a different shape from the substrate. Instead, it will fit somewhere else on the enzyme. And when it pushes into that other place of the enzyme pushes in, and that affects the shape, that sort of pushes out the shape of the active site. And so now that substrate can't fit in there anymore. It tries, but because the non-competitive inhibitor pushed the enzyme in at a different place, it bulges out at the active site and the substrate can't fit in there anymore. So again, you prevent the reaction from happening. You prevent the Pac-Man enzyme from eating its substrate. But in this case, you don't do it by competing for the active site. You don't do it by competing for this active site here. Instead, you do it by having the inhibitor bind somewhere else on the enzyme, and that just messes the enzyme's whole shape up. Notice this has nothing to do with concentration. It doesn't matter if you increase the concentration of the substrate more. If you increase this more, it still won't be able to fit in the active site. It doesn't matter. the reaction won't go. So in this case, the concentration of the substrate does not matter because the substrate and the inhibitor are not competing. So those are the two different types of inhibition, competitive and non-competitive. And now if they give some descriptions and they want you to fit the description to those two types of inhibition. So if the inhibitor has a structure similar to the substrate, then, as we saw, it is competitive. Here the substrate has this sort of pointy shape, and the inhibitor had that pointy shape, and that's why they both were competing for the active site. So this, A, is clearly competitive. Oops. Competitive. Okay. For B, the effect of the inhibitor cannot be reversed by adding more substrate. We saw how, with competitive inhibition, you can reverse the inhibition. You can take the inhibition away just by adding more substrate. If you can't reverse the inhibition by adding more substrate, then it must be the non-competitive inhibitor. As we saw here, no matter how many of these substrate molecules you have, they won't fit into the active site, and so it won't reverse the inhibition. So B would be a non-competitive inhibitor. C, it says the inhibitor competes with the substrate for the active site. And the word competes here should clearly recall competitive. As we saw in competitive inhibition, both the green and the orange, the substrate and the inhibitor, compete for the active site. So that is a competitive inhibitor. D says the structure of the inhibitor is not similar to the substrate. With competitive inhibition, we saw that the inhibitor is similar to the substrate. That's why they compete for the same spot. With the non-competitive inhibitor, you can see that the shape of the substrate and the shape of the inhibitor are different. That's why they're competing for different spots and are not competing. So for D, the structure of the inhibitor is not similar to the substrate. That is non-competitive inhibitor. And for E, it says the addition of more substrate reverses the inhibition. So we saw that that happens with competitive inhibition. When you have so much more substrate, when you have so much more substrate, it's more likely to get to the active site first. And so you can reverse the inhibition by having just more of the substrate. That only happens with competitive inhibition.